the training workshop 2, and let's begin with our training workshop. And this is today's rundowns. We will have 3 guests to share different topics with you, and each of the sharing we will have a Q&A section, and you may ask your question to the speaker. So let's invite our first speaker, Professor Zheng Yueping, and he is from the School of Government of Sun Yat-sen University, and he will share about public management in the era of big data, opportunities, challenges, and coping strategies in different populations. And let's welcome Professor Zheng.
Okay, good afternoon, everyone. It's my great honor to be here today. And today my topic is data government development in the era of big data and AI, progress and challenges. Okay, so the first part, evolution of technologies. So in the past 2 decades, we know a lot of progress, changes, innovations in the information technologies. And recently we call it digital technologies. There's a lot of different forms, types of technologies. So how can we better understand the evolution? So I try to divide these technologies into 4 different stages and 4 types. So in the first decade of this century, between 2000 and 2010, so the most important information technology is traditional internet. The government started to build their portals, and a lot of business companies, private sectors, started to provide information services through their website. And later on, after 2010, we see a lot of progress in the mobile technologies, like the smartphone, like the mobile applications. So today, more than 90% of information that we get is through the mobile internet and mobile applications. Guys, think about it. How long you stay? How long you use your social media, your mobile smartphone every day? Okay, in average, every day, more than 3 hours. More than 3 hours. So after 2015, no matter in United States, in Europe, or in China, a lot of policy has been made focusing on the big data. Because currently we have different devices, we have so many different platforms, all of this collect of information data every day. So how to use this data, how to manage this data, how to employ the value of the data to help us to serve the public, to make the better decision. So this is another stage, the big data and the weak artificial intelligence. So currently, we have more advanced the AI tools, like the large language modeling. We have ChatGPT, we have DeepSeek. We have different kinds of like tools for us to use to improve our work and afterlife. It's a strong artificial intelligence technologies. So in the past 2 decades or 25 years, we can divide the technologies into these 4 different stages. And we also can see them or divide them into 4 different types. The first one, platform channel, from PC to mobile, then to the Internet of Things. So this kind of technologies emphasize on how to share the information and how to share data. The second type of technology, like the big data, cloud computing, emphasize on the decision-making support. And also the process reshaping type of technologies like the OA. And also the task replacement currently the AI try to play their roles, not only can help us, but also replace some of the routine tasks in our everyday life and work. Okay, step into the new era of strong AI. Different from the AI in the past decade or past 20 years, currently the large language modeling and advanced AI tools based on the recent report and studies, we found that they have stronger capability to understand us, communicate with us, and do a lot of things in a more efficient and effective way. That you see in many different fields and contexts, this AI tools perform better than us. Okay, second, progress in the digital government development. Just now we try to divide the technologies development in the past two decades into different stages and types. So what kind of practice in the digital government development occurred in mainland China? How local government adopt the information technology, the digital technologies into their practice, into their services, into their management, and into their policy making. So I want to share some examples with you guys. First, the digital platform building. We know that the local governments have the responsibility to serve the public. They need to provide convenient services and information to the public. So they adopt a lot of digital tools, channels, platforms to make their service more convenient, more efficient. So in 1999, that's 26 years ago, in mainland China, we have project from the national level. They started to provide and build the government official portal. Later on, after 2010, especially after 2012, a lot of mobile applications have been built up by local government to provide information and services. So currently, when we want to apply some certifications and license, we can go to the offline services center. We also can go to the government website. And we also can use the WeChat and Alipay to get government services. That's one kind of like the PPP, public, private, and partnership. So today, you can get more than 100 types of government services through your WeChat and through your Alipay. So this is like digital platform building. We have the government website, we have the mobile applications, we have the social media, and we also have the WeChat and the Alipay that can provide the government services. Okay, the second, digital transformation of traditional services. Since 2017, that's 8 years ago, our team and our center started to do research in the government service hotline. In the United States, it's 911. It's a 311. 911 is emergency. 311 is non-emergency. In mainland China, we have 1, 2, 3, 4, 5 hotline center. So guys, anytime, if you want to ask a question, if you want to find the public transportation services, if you want to ask a question, inquiry about the policies, you can make a phone call 1, 2, 3, 4, 5. Okay, so how long we have built this 1, 2, 3, 4, 5 hotline? More than 40 years. But in the past 10 years, there's a lot of changes in this government service hotline. You can get service not only through your phone call, dial the 1, 2, 3, 4, 5, but you can also use the government website use mobile applications, use social media, use WeChat and Alipay to get the 1, 2, 3, 4, 5 services. And they also try to use technology to explore the value of the data. For example, in the city of Guangzhou, okay, how many people live in the city of Guangzhou? 22 million. How many phone calls this government service hotline center received each year? 20 million. 20 million phone calls, huge data, right? They try to use technology to explore the value of the phone call data, to try to better identify people's needs, demands, and then enable the decision-making process and policy-making process to be more accurate and scientific. So today, the 1, 2, 3, 4, 5 is not the traditional services that we saw 10 or 20 years ago. A lot of change has been happened. And also the offline service center is the same. Third, use digital technology to improve regulations and management, like the food safety regulation. Currently, the government motivates a lot of restaurants to put a camera in their kitchen. And then they motivate this restaurant to share data with them. In this way, they can analyze the data and use the camera, use AI technology to guarantee that your kitchen is clean, the food is safe. The city of Guiyang already did some experiment. They try to use AI, use big data to guarantee that the restaurant in the city is clean, the food is safe. And also use digital technology to promote the decision and the policy making. So this is the book that we released last December to discuss how to use the big data and AI to improve the public nutrition and also to improve the decision making. Like the pollution. In the city of Guangzhou, we face challenge in the air pollution and the water pollution. A lot of rivers, lakes, right? So how to guarantee that of a world of rivers and lakes, the water is clean? How to address the challenge of the water pollution? If this lake or this river is polluted, how to identify this issue as soon as possible? We collaborate with some departments and some IT companies. And we try to put some sensors in the river, in the lake, and we collect data. And we try to build up the rules and regulations to find a way how to identify the pollution once the water is polluted. City brand. Where does the term come from? City of Hangzhou. City of Hangzhou. Okay. Guys, do you like the term city brand? Okay. Do you believe that a city like Hong Kong, Shenzhen, can be managed, run just based on a brand, a super computer system? Do you think so? It's so hard. It's so hard. A lot of challenges. A lot of challenges. But the idea underlining this term is valuable. Why? Because a lot of decision making and policy making is fragmented. For example, transportation. The department chair always made a decision just considering about this department, just considering about the transportation system, efficiency, services. But the transportation is related to a lot of different fields, like the pollution, right? And housing, right? And the city of Guangzhou have 11 districts. And only the district of Baiyun have population more than, let me see, is 4 million. Just the district of Baiyun, the population is more than 4 million. What does it mean? 4 million. This district in Europe, in United States, is a very, very large city. It's very complex. It's very complex. City of Guangzhou have 22 million people live there, have more than 1 million public sectors, companies. It's so complex. And in this city, more than 10 million people, they work here. But they do not have the hukou of Guangzhou. They come from other cities and provinces. It's very complex. Every day, a lot of changes. And the city brand, they would like to motivate the decision makers, the policy makers, analyze the issues, think the issues, the changes in a collaborative way. Enable city to learn, to think, and to analyze. Okay. The third part. This is the part I want to emphasize today. Reflections on dilemmas of digital government development. We have a lot of digital tools, digital technologies. We have big data. We have artificial language. It seems like we can do a lot of things. We can do everything. And we see a lot of progress in the past 10 years at the local level in mainland China. Government services, policy making. The government uses technology to improve the service delivery, to promote the regulation, the policy making, decision making, so on and so forth. But what I want to emphasize is that we're facing a lot of challenges. We're facing a lot of dilemmas in the digital government development. Okay, first, we do have a lot of digital platforms. We have government website, applications, government social media, so on and so forth. But the problem is that how many people are using these platforms? Okay. The data shows that in average, one person go to the government website. Just a guess, how many times for a year? Per person for a whole year, go to government website. Do you often go to government website of the Hong Kong? No. Okay, data shows that just once per person for a whole year. We spend a lot of money to build the government website, but not many people go to the government website to download the form, to get services. We have many different mobile applications built up by different departments. We have many government social media, but people do not have interest to visit and use them. So this is one manuscript I published with another professor in Shandong University named Sun Zongfeng. We analyzed the government Weibo. It's an official government, it's a official government social media account, just like Twitter. We analyze all the government Weibo of the 228 cities between 2011 and 2017. And we found that no. In average, each account, each city, just post more than 10 times a day. But no people just waited, read this post. We waste a lot of resources. So in the future, what should we do? Continue to manage and maintain this platform? No. People do not use Weibo in the demand side. But in the provision side, the government still put a lot of resources to maintain this platform. Right? It's not reasonable. Second, government services. In the past 10 years, local live governments have strong willingness to build up their applications, mobile applications. And currently, at city level and at district level, the local governments still input a lot of resources to build and to maintain their mobile applications. They want to motivate more people to use these mobile applications. But what I want to emphasize is that no channel and platform is better than another. We need to combine them as a whole. Currently, we have too many different channels and platforms. They're so fragmented. The mobile platform, yes, they have advantages, but they also have disadvantages. If the services is quite complex, which means that you need to type a lot of information, you need to upload a lot of documents. In this situation, the mobile platform, even the government website, is not that convenient. The most convenient way is just go to the offline service center. That's it. When we provide services, when we provide digital services, we need to always know that all the different channels have their relative advantages and disadvantages. The local government needs to put them together to service as a whole in a more effective and efficient way. Okay, one-stop services. I started to pursue my doctorate degree in Rutgers University since 2011, and I worked in the e-governance center. My advisor is Professor Mark Hoser. Okay, that's 14 years ago. 14 years ago, we started to talk about the one-stop e-services. We motivate the local government in United States, in the state of New Jersey, to build up one-stop government website, put a lot of information and services, put the services from different departments together to build up one-stop services center. Okay, today we do the similar things. We want to build up one-stop mobile applications. We want to put all of these information services, no matter to our citizens or no matter to the private sectors, just with one application. Guys, think about it. If there one application provided by the government can provide all the information and services to you and all the other different business sectors, do you really want to use this application? To what extent this application can be convenient and efficient? The reality is no. In the city of Guangzhou, we have 11 districts, 22 million people, more than 1 million business sectors. The government wants to just put all these information services in one application and call it one service center. No. Although it's still one application, but if you go into the application, still the service is fragmented. It's difficult to achieve multiple departments, complex scenarios, and the intersecting functions are hard to integrate into one-stop platform. The result is that while it's easy to enter the application, it's difficult to find the services. The path is not well designed, resulting in poor experiences. The third one is data governance. The data governance. We know that government have a lot of data, and we motivate the government to open their data. Since 2012, city of Shanghai started to build up their open government portal. 13 years later, currently, more than 150 cities have their open government website. They provide a lot of data to the public. And our center collaborate with several departments in city of Guangzhou at the city level and also at the province level. Many departments collaborate with us to try to improve their capabilities in the data management, data governance, and also in the data usage. All of them expect to have high quality data. High quality data. Guys, where data come from? We have a lot of cameras, we have a lot of sensors, we have a lot of platforms, we have a lot of applications, but still today, a lot of data is collected by the first line employees. There's a conflict. We're writing some manuscript based on the case studies. In the past, the first line employees just want to finish their everyday routine task, right? That's it. They want to use technology to improve their efficiency. But later on, their department chair, their managers ask them not only use technology to finish their everyday task, but also collect data. So if you do the interview to the first line employees, you find that today they face a lot of burden, not only to finish their routine task, but also help their department to collect a lot of data. Second, once they collect data, once they submit the data, who will benefit from this data? The decision makers, which means that the first line employees, they collect data, they submit, but the department chair, the managers use data to better manage and regulate their behaviors. So the conflicts there, and also the data sharing. We read some manuscript in this feed, and we found that although we emphasize for many times that data sharing is very important, data open is very important, but if you do case studies, if you interview with different department chair, you find that they do not have the willingness to share the data. Okay. The e-participation. the e-participation through diverse channels. In the past 20 years, many literature in the citizen participation raise one question: why technology cannot promote the citizen participation? The barriers in the citizen participation refer to many different aspects: information, knowledge, platform, channels, cost, risk, so on and so forth. And today we have a lot of channels. And we need to think about and to analyze the relative advantages and disadvantages of these channels when people are using them to interact with the government. For example, the government website. It's more appropriate for the government website to provide the routine information like the policies and the responsibilities of each department, not the emergency information provision. The government social media has relative advantage to provide the emergency information, but not the certification, application, this kind of like interaction and service delivery. So which means that we have diverse channels, and each channels, they have their relative advantage when they provide information, when they provide services, and when the government interact with the public in the different context. So we need to analyze them, and we need to combine them together. Fifth point, the citizen-oriented AI government service development. In the past 3 years, we released several reports to evaluate how local government use AI technologies to deliver services. We did a lot of experiments to the 36 large cities in mainland China in the past 3 years. We released the report with the IFLA-Tech. And we found that on one hand, all of us, all the local government, they try to adopt AI. They try to use AI. They have strong willingness to learn and use AI. But on the other hand, the AI services, the quality is very, very poor. In this May, just 4 months ago, we released another report, and we found that among the 36 large cities in mainland China, when we examine and evaluate the performance, the AI services, we found that less than 10 cities, their AI services can run very well. A lot of problems. And we also found that in the demand and usage side, people have quite low usage to these AI services. Even though that some of the services have been improved, innovated with the AI technologies, but when we do surveys and interview to the public, we found that no, the usage level is very, very low to these AI services. We can see the gap between the provision side and the usage side. 6, the PPP. If you ask me the question, what kind of factors drive the digital government development and the innovations in the past 10 years? I will tell you that one important drive is the PPP. In the past 10 years, under the help from the Huawei, Alibaba, and Tencent, the local government, they have more opportunity to learn the new technologies, to understand technology, to use the technologies. And today, if you go to city of Shenzhen, Guangzhou, Hangzhou, and other cities, you find that many digital government projects are run by these big IT giants. So the PPP in the past 10 years contribute to the progress and the innovations in the digital government development, in smart city development. But another point and the challenge is that a lot of conflicts. Sometimes the PPP, the collaboration between public and private sectors, they waste resources, and many of them failed. And also the privacy protection. Not only the conflicts, not only the outcome, another challenge is that how to protect our privacy and how to protect the data security when the public sectors they collaborate with private sectors. How can they guarantee that the data is still safe? It's still a big challenge. The PPP dilemmas in digital government development. Hard to achieve the goals. Cost benefits mismatch. Conflicts exist. Risk and challenges. A lot of failures. Currently, I have several PhD students. We work together, try to uncover the mechanism and explore the determinants and barriers. Collaborations among different stakeholders in the AI government development. And also the public value building in the digital government development. There are several students in my center. They're doing research, try to discuss that. If the digital government services fail, who will the public blame? To what extent the digital government services fail, resulting in the decrease of the satisfaction and the trust of citizens towards the public? If the services is provided not only by government but also instead of through a PPP, like the form, who will the public blame when the services fail, when the project fail? It's quite interesting because the data shows that higher than 70% of the digital government project fail in the end. Not only waste a lot of resources, but also do harm to the public value building. Failure, burden, and conflicts. First, return to governance. So when we talk about governance, we mean three groups, and the three groups of relationship. The first one, government to society. Second one, government to market. The third one, government to government. And among these three relationships, there are two types of element flow. The first one is virtual element. The second one is physical element, like the human resources, capital, goods, space, so on and so forth. The rules of governments, why we talk about the public administration, why we try to find a way to improve the governments, because we want to promote the element flow. We want to build a better relationship among these three groups and stakeholders. We try to build a better channels to improve the efficiency of the element flow. We try to regulate and set rules to regulate the power and take responsibilities. We also want to support build up a supportive environment. So if we follow this logic, we found that in the past 10 or 20 years, we're facing a lot of failure of the technology use. First, has technology changed governance, channels, process, system management, goals, and paradigms? Second, has technology empowered governance, enhanced and improvement, regulation, support? Has technology created public value? To what extent technology usage adoption build up or promote the effectiveness, collaboration, resilience, and equity? No. We found that a lot of failures and a lot of burdens. Digital government development, on one hand, bring a lot of benefits to the society. We see the convenience and the efficiency has been improved. We see that the policy-making, decision-making has been improved, but we cannot ignore that a lot of burden, not only to the government, but also to the citizens, to the public, and to private sectors. First, to the government. A lot of administrative burden and the cost. Not only the money, but also a lot of implicit the cost and also the administrative risks. Second, citizen burden. We keep building up these new channels and platforms. But all of these changes bring a lot of learning cost to the public. The compliance cost and also psychological cost to the public. They need to try their best to learn the new technology, learn new tools, platforms to get the information services. And also the economic and the social cost. The policy making in the digital government development, to some extent, is a signal in the technology market and development. And also the digital government development, the PPP, the decision making and policy making influence the market competition and stability. All of this bring the economic and the social cost and risk that we cannot ignore. The conflicts between technology and the government. The left side expectations. We expect that the technologies contribute to the transformation of the government and the governance. But the reality is that no, it's not that easy, right? A lot of conflicts and the contradictions occurred in this process. The inter-subject conflicts, new roles. In the future, in the next 3 and 5 years, technologies become more complex. They no longer just a simple tool, new structure. When the technologies become more and more advanced, stronger and stronger, a new relationship will be formed between our human beings and these machines. And in the next 3 and 5 years, we're facing a lot of uncertainty in our environment and also the international competition, so on and so forth. And also ethical conflicts. A survey in Japan shows that, 2,283 males aged 15 to 26 in Japan, the results show that over 60% of them are willing to date AI. Conclusion. In the past 10 and 20 years, a lot of progress has been made. We see a lot of innovations. We have a lot of new technology tools. We always believe that when we have new advanced tools, we can improve our public administration. We can improve our service delivery. We can improve our policy making and decision making process. Reality is no. Technology and penetration, they're separated. In many situations, a lot of conflicts. Not only the benefits, not only the opportunities, but also the risk, challenges, burden, and the cost. Second, technologies have a lot of limitations, especially in the penetration, in the context of different government running and management. Just like today, when we talk about how advanced is the AI, but also when we use AI in the penetration, we found that many things, many situations and the context, this AI cannot do meaningful work. We cannot use them because a lot of risk and the challenges. Third, returning to the governance, emphasizing value. When we talk about the digital government development, when we want to promote the digital government development, we cannot only emphasize on the advanced tools. We need to emphasize the demand side, the usage. We want to meet the expectations of our users. We need to emphasize what they want, not only what we can provide, right? Guys, think about it. The digital divide. The digital divide had been discussed for more than 30 years. A lot of manuscripts, a lot of articles try to uncover the mechanism and try to find a solution to the digital divide to address this issue. But 30 years later, today, we can see that the digital divide between the developing and developed countries become larger and larger. And among cities, it's the same. We see that the digital divide between the middle and the west, the cities, and the east and south coastline, we see that the gap is larger and larger. What should we do? Right? We cannot always emphasize the advanced tools. We need to return to governance, and we need to emphasize what do we want, what do we expect, and emphasize on the value building. Okay, guys, that's all for today. Thanks.
Okay, so we have our second sharing from Professor Yimeng. Yeah, and he is from the Faculty of Architecture of the University of Hong Kong, and he will share about spatial data in healthcare and well-being of different populations. And let's pass the time to Professor Song.
Thank you. Just appreciate. Thank you so much for the kind introduction. It's very nice to be here, and I appreciate all of you being here. So my name is Yimeng Song. I'm currently working at the University of Hong Kong as an assistant professor. So today we are going to talk about the topic. I changed it a little bit. So it is about geoinformation science for healthy or smart cities. My things is a little bit technical. So if you feel it is a little bit hard for you to understand, just show me your hands and I can give me a little bit more details about what I'm trying to share with you. So please allow me to start by telling you a little background on myself. I started my academic journey in geoinformation science, and I received my geoinformation science training in China, Hong Kong, and the United States. And when I work in different GIS. GIS is Geoinformation Science. Okay, so that kind of training with doing different kind of technical things like geospatial big data fusion. It is kind of that combine different kind of geospatial data together to focus on some real world applications. And the real-time GIS modeling, it is kind of a way that using different census data to monitoring what is happening right now in the real world, as well as the geospatial artificial intelligence. Artificial intelligence is quite famous right now, right? Machine learning, deep learning, large language model, that kind of things. But geoinformation, geographical artificial intelligence, that we do not only consider the data that we usually use, but also using the data have a geoinformation, that kind of information, okay? So the last day is kind of environmental epidemiology technique. It is more related to environmental health. But throughout my academic journey, I became increasingly aware with some of the big problems in the context of urbanization and climate change. Okay, I'm referring to the urban and environmental hazards like air pollution, wildfire, which is happening a lot in South America, right? As well as flooding. Probably in the several days, Hong Kong will have similar kind of environmental hazards because another hurricane typhoon is coming, right? And as well as the heat waves, extreme high temperature, and hurricane, typhoon, right? As well as the limited exercise to nature environment like green space or blue space. But what really stand out to me is that these hazards and the challenges do not affect all areas equally. We can see clear disparities, inequalities, not only within the city, but also across regions globally. So it is kind of do not all the people facing similar situations, similar environmental pollution or hazards, but different people actually having different kind of that kind of a terrible situation. And this challenge and hazards also contribute to healthy issue, including both the physical and the mental health issue, as well as worsened health inequalities. So healthy city is therefore becoming more and more popular because it is kind of the things that are trying to address this theories of environmental and urban issues. So my research is mainly focused on how to leverage the geoinformation data and the cutting edge advanced AI technique to envision a healthy city to have the ability to address that kind of issues. So in my today's presentation, I'm trying to explain how can this data and the technique can contribute to this kind of things through three aspects, three dimensions. The first one is about people, and the second one is about environment, and the last one is about health. So I'm going to start with people. So in this part, I'm going to introduce how the geospatial data can help us to figure out, to examine the real-time population distribution, as well as the human mobility issues, because both of them are the fundamental for us to understand any human-centric analysis and applications in the context of a healthy or smart cities. So let us start with the dimension of a people. This is a photo that taken after the Hurricane Helen. The name of it, the name of the hurricane, which struck at the North Central Florida last year, 2024 actually. But before the hurricane, a local organization, an NGO, actually signed an evacuation to the people who living in a disadvantaged community. So as you see, this advantage is kind of not, this community is not that kind of fancy, but actually it is people who actually from the South America who speak a lot, most of them speak Spanish. So in America, it's kind of advanced people, most of them, not all of them. Most of them are living in a house that we usually call it mobile homes. It is actually very especially dangerous during hurricane, very easy to be broken. But however, most of people do not really leave when the hurricane comes. But the government and the NGO, the local organization, do not really know because they do not have the ability to know where people really are at that time. So I think this fact highlights the needs of the information of real-time population distribution, the information of them, to ensure the timely and effectively disaster response, as well as other applications, as what I listed here, such as the environmental exposure, traffic management, as well as urban planning. So the question here is, where are people located, or how can I get this kind of information? Unfortunately, the fact is few data can help us. It is kind of a really difficult things. So if you have a geography or environmental background, you probably know there are some data that can be used to help us figure out this data. For example, some widely used graded population. So you can see there's some data can provide the annual population distribution on the Earth's surface. Two of them is Landscan and WorldPop, the name of this kind of data site. But they only provide annually updated information, which means that we could not use it to identify the real-time situation of the patterns of population's distribution. But some efforts has also attempted to address this issue by integrating geo-targeted information from social media and mobile phones. But however, this framework only provides the resolution to like monthly or separated to daytime and non-time. So simply speaking, this data try to address this issue, but the efforts is also limited, which means it still cannot be used to help us to identify the real-time population distribution. So my work here is to try to develop a framework to do the real-time population mapping, to make the data do not only have a fine spatial resolution and good accuracy, but also high temporal resolutions. The basic idea, it is a little bit difficult for some of you, but I can try to explain it. So how can we mapping population distribution? Simply speaking, the first things that we have a census data, the ground truth data, right? So the first things that we are trying to identify the relationship between the ground truth data with different kind of geographic variables. And then we can use these variables to make a prediction to identify the real-time population distribution. So which means that we need a lot of data and use this data to predict the population's distribution in a real-time context. So a little bit more technical things is that before I try to explain how it works, I must to let you know why it is difficult, why there's a limited work has been done to address this issue, why there's only almost no data can help us to know the real-time population distribution. So the first thing is about the model selection. And excuse me, kind of a little bit too low for me to, thank you. So the first thing is actually the model selection. We know that the relationship between census data and various of geographic variables is kind of a complex. So which model can help us to make the prediction is the first question need to be answered. And if you have the background of machine learning or artificial intelligence, you probably know that there is a theory, we call it no free lunch theorem, which just means that we cannot expect a single model can help us to figure out all this complex association effectively. So we kind of need to combine different models together. So which model can be used and how to combine them is the first question need to be answered. The first one is what we call the spatial non-stationarity, which just means that we have a model and we can use it to predict the population distribution for some reasons. But this model cannot be effectively used for everywhere. If we use it for Beijing, probably it have a good prediction performance. But if we use it for another city, for example, Hong Kong, the performance will becoming poor, probably. So we need to address this issue. And the last one is we call the temporal generalization. It's similar like the spatial non-stationarity, but it's more focused on the temporal limitations of the models, which just means because we need to do the real-time population prediction. The temporal generalization means the model can have a good performance for some specific time period. For example, like 1 a.m. in the morning. But if can have a good performance, but if we use it directly to make the prediction for a different time, like 9 p.m. in the afternoon, it will become poor. So here I list the three of the major challenges that we need to address when we try to conduct the real-time population mapping. So I divide the framework construction into 3 steps. And the first one is human footprint zone identification. So simply speaking, that we need to identify an area which to make sure that the people are spatially linked to the area with human activities, instead of every corner of the Earth's surface, right? For example, there's no reason that we put people into the middle of the forest or the cold regions or the deserts, right? Because these regions typically have almost no populations and activity, human activities, right? So how to identify these areas? Simply speaking, I collected a lot of data, a lot of maps, a lot of layer, and all this layer kind of have a relatively high relationship between human activities in the space. For example, the road density. There's a roads, so we can kind of make sure people will be there, right? And for example, the POI density. POI is point of interest. Simply speaking, one POI usually means the location of the hospital, the schools, supermarket, grocery stores, gyms, that kind of things. So if we have that kind of things, probably people will be there, right? And as well as human digital footprint, which is the locations that people using mobile phone or social media. If you share your locations or your signals will be detected by some by some sensors, your information of your location will be records. So we collect them together and created a kind of map. So which means that when here are a social media creator or a mobile phone user, there must probably have a very large probability people will be there, right? So simply speaking, we combine them together and to make the kind of the maximum probability map of human footprint zone. So the first things is this kind of map. You see the red-green regions is the family human footprint zones. And later the population mapping will be only conducted within these areas. So the second things, as I just introduced, we are going to identify the relationship between the census data, which is the ground truth data, and the various of geographic variables to use it to make the prediction, right? So the first of the things is we need to collect a bunch of a data layer to help us generate these variables. So I actually collected a lot of data, including census data at a county level, which will be used as the ground truth data for our prediction and model training and variation, right? And the next is the geospatial big data from mobile phones. So the data that I used is actually from Tencent, right? We know that when we use this, the apps, that they usually have the location-based service. And when you use this apps, your locations will probably be recorded, and this information can be used for a lot of analysis. So in my applications, I'm going to use it as one of the variables to help me to make the real-time population distribution. And beyond these two very important data, I also collect a series of the remote sensing data. Is kind of the data that captured from the sensors on the satellite. It's kind of the picture of the Earth's surface, including different kind of data. For example, the line side. Line side is actually the real. It's simply speaking, it's just the picture of the Earth's surface. And the nighttime light is the picture taken during the night, and that kind of things, land use and land cover, right? Different kind of a data layer. So I then use this data layer to generate 15 different geographic variables, which all of these variables have a potential predictive power for population at different scale. So this is what I did. So after I just have these variables, the next things is I'm going to do the prediction, right? I'm going to identify the association between the real population between and these variables, these geographic variables. So if you still remember, the first challenge is the data selection. A little bit technical things here is actually we have a lot of model can use, and the model that I am using here is what we call is the automatic assemble model. This is a model developed by Amazon. It is quite powerful, but also user friendly. So simply speaking, you have already generated these geographic variables, and you just need to put in the model. This model can help you finish all the very technical things like the future engineering, the hyperparameter training, that kind of things. If you do not have some background in artificial intelligence or machine learning, just forget it, okay? So it is kind of powerful, and it can help us to select the good model can be used for the prediction. And if you have the background in the machine learning, you can see this model is actually created by using a series of different, very powerful and as well as cutting edge base machine learning model, as well as the neural network also used as the base model. And they use it in the multi-layer stacking strategy, right? They train a model and use the prediction for another training, and then train again, and until it have a relatively stable and a robust prediction. So simply speaking, this is the strategy that I used for the model selection. And the next one is the spatial non-stationarity, which means that if you still remember, the model can have a very good performance for some regions, for example, Beijing, right? But if we use it for another city like Hong Kong, it is becoming not that good. So how to adjust it? So the strategy that I used is what we call the geographic weighted. If you have the background in geography, you probably know this technique. Simply speaking, it's kind of make the model have the ability to address the prediction individually for different regions, and to make the performance not only have an overall performance, but also have a locally relatively good performance. So this is probably a little bit technical. This is how it really works. They use a Gaussian weighted regression technique to make it have the relatively good performance for different regions. And the last one is the prediction. We have the association, right? We use a kind of a powerful prediction model, and then we have the relationship between the census data and the various of geographic variables, and we have the association. So the next thing is use this association to make the prediction. But the prediction is focusing on real-time population distribution, right? So what I did is I developed a multi-prediction framework. And this framework can help me address the temporal general relation issues. So simply speaking, I do the prediction for a relatively large scale, county level, and then followed by a correction to make sure the performance, the prediction at the county level is relatively good. I then use this prediction to further correct the prediction at a grade level. Grade level means the relatively fine scale, because what I really want to see is provide detailed population distribution information in both time and in terms of both time, the temporal resolution and the spatial resolution. Both of them should be fine, right? So here is the result, the final result. You can see what we finally received is the hourly population distribution for the whole country of China. And the spatial resolution is 1 kilometers, which means each pixel on the map represent the dynamic population change within the 1 kilometers areas. And if you see that kind of figure, the sub-figure 1, you can see the association between the population distribution in Shanghai during different time. And also in some period, there's a dramatically change in terms of the population distribution. For example, 7 a.m., because most of the people go to work. For example, the night 10 p.m., right? Probably a lot of people finally go back to home. And I also make a comparison using the map. You can see the subfigure B. And the green areas actually means the population during the daytime is kind of much higher compared to the nighttime, which means that is a kind of the CBD areas of Shanghai. And most of the people will be working there during the daytime, right? And the red areas on the map means there are more people during the nighttime compared to the daytime, which means that most of the area are people's where their home are, right? So they go back to their home during the night. So most of the people, more people will be there during the nighttime. So the most important things for this application is make sure that your mapping, your result is good enough, have a relatively relatively good accuracy. So then I make a evaluation for my result, and it seems kind of very good. If you have a statistical background, you probably know we use R-squared to make the evaluation. And at a county level, the R-squared reached 0.99 is kind of a very good, right? But also a county level is not good enough because it is quite large. We also make the evaluation at a great scale. And the result, the accuracy level is also kind of relatively good. The R-squared of it is 0.92, which means even at a relatively fine spatial scale, the accuracy of it is also good enough. So some takeaway for this part about the population mapping, right? So real-time population mapping is kind of a challenging thing, that we have a lot of technical challenges should be addressed before we can mapping out the real-time population distribution. So the work that I just show you is the things that I did to address these challenges. And the data is actually very important. I mean, the real-time population data. So it can be used for a lot of environmental and urban analysis and applications. For example, the urban structure and transportation, right? If you are someone who are interested in urban transport, the real-time population distribution is quite important, right? And then land use and energy consumption, right? If you are you have an environmental background, the energy consumption is really something that you are quite interested in. And the last one is environmental and disaster management. It's also something that I'm going to talk a little bit more in my today's presentation later. Okay. Also beyond the population dynamic distribution, actually human mobility is also something quite important. So I also have some work that I focus on to identify the intra and intercity population mobility. For example, one of my work is trying to identify the interpopulation movement across the whole China. Okay, and this data can help us to identify the human mobility patterns during different time of the year. And this data is actually very important. For example, we use it to contribute to some COVID-19 analysis, which published in Science and PNAS, very high impact journals, to help us to identify what is happening in terms of the COVID-19 at the very beginning of the pandemic. Okay, so after I have already shared some technique, some research, some analysis about how we can use the geoinformation data to identify the spatial and temporal patterns of a population of people. The next things that I'm going to share with you is about the environment. So what I'm quite interested in to try to identify after we know where people are, so I'm quite interested to know how do people interact with their ambient environment, right? How do people exposed to different environment? And if you still remember at the very beginning, I introduced to you, actually different people are facing different environmental challenges, facing different environmental hazards. So I would also like to know what is the inequality in terms of the environmental exposure. So the environmental hazard and challenge actually can relate it to a series of different environmental factors. For example, the green space, air pollution, blue space, right? Wildfire, extreme temperature, as well as the flooding. But in my today's presentation, I'm going to tell a little bit more about the green space. Very important urban environmental factors, especially for the development of a healthy city. Right? So why it is important? Because it is unique and important. It can not only help us mitigate many environmental hazards and challenges, but also have a number of benefit on both physical and mental health of people, right? But as I introduced, the problem of it is not equally can be enjoyed by the population, right? So what is the real situation of the population exposed to this environment? How are people truly exposed to such amazing green environment is the things that we actually want to figure out. So before I discuss what is how we do this kind of analysis, I first need to make a definition about what is green spaces. So in my work, green space is defined as any areas covered by vegetation. It's a quite simple ways to define the green spaces. And we do not care about the type of it, the size of it, as well as the function of it. All the areas that are covered by green vegetations will be considered. So I also use some geospatial technique to help us to answer those questions. So the first things is actually to figure out the distribution of green spaces. So here I also use a technique which we call remote sensing, that we use a technique to figure out very detailed distribution of a green space distribution. Very detailed information about green space distribution. Because it is a little bit too technical, I do not provide more detail about the technical things. But simply speaking, we use remote sensing data and use a technique to extract, to figure out the spatial patterns of the green space distribution. Okay, and the next thing is actually quite important. So it is things that we need to really consider when we're trying to figure out how do people really expose to their ambient environment. So we know that we just discussed there's a population distribution dynamic as well as the human mobility issues, which means that people do not actually located in one place forever, right? We do a lot of different things. We go to work, go to gym, grocery store, supermarket. We do a lot of different activities. And we also change our corresponding environment that we expose to. So when we're trying to answer the question of how do people really expose to their ambient environment, we need actually take their dynamic change of the location into consideration, right? So the work that I did is I used hourly population data that I just introduced to you how I created, and combined green space distribution data that I use remote sensing technique to mapping out, combine together and to try and figure out how do people, to overlay them together, to trying to figure out how do people really exposed to green space in each hours across one day. And here are some results I would like to show you, actually very interesting. So this map is trying to show you that people are really dynamically changed in terms of the green space exposure. So here's a city, Guilin. Anyone of you from the city? No, okay. So in the city is very interesting because you can see that people during the nighttime exposed to more green space compared to the daytime, right? Which means that the home where they live actually have a relatively good green environment compared to the place that most of them they work in. And Tianjin have an opposite situation, which means that people exposed to more green space during daytime compared to nighttime, which means that workplace is a little bit more greener, right, compared to the home, the environment around their homes. And Huizhou is quite interesting because people are exposed to more green space at some specific time period. For example, at 7 o'clock in the morning, at noon at 12 o'clock, and around 5 and 6 o'clock in the afternoon, as well as 10 o'clock in the afternoon. So if you think a little bit the reason behind it, you may know that during this time period, people actually go outside to do some non-work activities. For example, they go to work in the morning, they go to lunch in the afternoon, and go back home at around 5 or 6 o'clock, and it's probably some young people finally go back home at 10 to 11 o'clock at night, right? So this activity make them have the probability to expose to the outdoor environment, which make them have more opportunity to expose to green environment. And the last city is Yinchuan. I put it here because it's a little bit more different. It's a little bit different from the other cities because people do exposed to a little bit more green spaces in the weekdays compared to the weekends. We then do the analysis for most of the major cities in China, and we found out the green space exposure is 35%, which just means actually we measure the green space exposure like this way, like when we are sitting here, right, and we use a buffer like a circle around you, and then we calculate the circle is a 1 kilometer circle, 1 kilometer buffer. And what we do is we calculate the green space coverage within this buffer, within the circle. So it is kind of 30%, which means average speaking, right? The average green space for most of the major cities in China is 75%. And we then make a comparison to green space coverage. Green space coverage is kind of a very commonly used metric, especially in urban planning. And you probably see a lot of documents from the governments telling you that the green space coverage is how large, how high, how low. This kind of a metric do not consider the population's distribution, right? They do not care about where people are, but just calculate the average green space within their cities. So you can see the comparison of them. They're actually a very large gap. Because what we did is to measure how much green space people are really exposed to, which consider their surroundings as well as where the people's dynamic change. But if we do not consider it, it seems kind of large. But if we consider it, it's very low, right? Which means that most of the green space in China are actually do not located around people. They are far away from us, which means that it is quite hard for us to enjoy. The last things that we did is make an inequality to identify the inequality in terms of the green space distribution. And I borrow a metric from the economic. It is the Gini index. Simply speaking, the Gini index can help us to identify the inequality in a relatively easy way. And if the index is equal to 0, it means that people are equally exposed to the same levels of a green space exposure, green space level. But if equal to 1, this means that only very, very tiny of people, a small number of people can enjoy a lot of green space, but most of the people can almost not enjoy any green spaces. So we make the calculation for, again, for most of the major cities, it's about more than 300. And we see the Gini index is 0.67. It's kind of a very high, actually, which means that even though some cities have a relatively green space coverage, but the inequality issues are kind of very high, which means that not all the people are equally have the ability to enjoy this amazing green environment. And we also make a comparison for most of the large cities across the globe, across the world. And we take 1,000 cities into consideration and make the comparison of the cities located in global south and global north. Global south is most of the cities kind of in developing or underdeveloping levels, and global north, which means that the city or the country is a kind of a developed country or cities. So it is quite interesting. The people who live in undergrad, in developing or undergrad living cities and countries also have a limited green space can be enjoyed. So so this technique can not only help us to focus on answers about the green space, but also can be used for the other analysis as well as other environmental factors. For example, the air pollution, flooding of blue spaces, as well as some environmental hazards, which is very important in recent years of like the wildfire and extreme temperature is happening in the context of climate change. So some takeaways. So we are trying to identify how do people exposed to environment. The important things is that we need to take your dynamic distribution into consideration, right? And we also need to have the ability to figure out the spatial and the temporal details of the environmental factors. So they are quite important for us to understand or answer the question like the real-time exposure as different kind of environmental factors exposure, for example, the green space as well as the air pollution. So it seems that I do not have a lot of time, so please allow me to make a brief introduction about the last part about health. So actually, we have a lot of geospatial data, and this data can not only help us to identify the environmental things or population things, but also can help us to mentoring some health-related situations about population. So here is an example that I did that using the population's internet behaviors to identify some health situation of a population. So how the internet behaviors can generated from the data when we're using that created when we're using search engine like Google or Baidu. If you're from mainland China, you probably know it a lot, right? As well as some social media like Twitter, nowadays we call it X, Facebook, Instagram, and TikTok, etc. We use it, we share information and also create data. And this data can help us to do analysis about people's health, humans' health. So here is an example that I used the data generated from search engine to focus on the mental health issues during the beginning of a COVID-19 pandemic. So the keywords that I use here is the anxiety. It is a very classical mental health issues, and it's happened a lot across students and people, everyone actually. So I want to see if there are some mental health issues when COVID-19 happened. And also I collect the data from 2020 and make a comparison from the data generated in 2019 and 2018. So the interesting outcome of it is we can see that more people are trying to use this search engine to find some information about anxiety, which can be used as information to identify the trends of people's mental health. And if we do a city-based analysis as well as a province-based analysis, we can also identify similar spatial and temporal patterns about the mental health issues across China during the beginning of the COVID-19 pandemic. And more importantly, the spatial data can also help us to do some environmental epidemiology work. So I just want to present one example that actually in environmental epidemiology analysis, we also quite interesting to identify the inequality issues, the disparity issues. And one of the quite famous topic is to make a comparison of urban and rural, right? So the work that I present here is I trying to using different ways to define what is urban and rural. The interesting thing is because urban or rural is a quite of very complex socioeconomic or physical concept, we cannot easily define it in using simple ways. So that is why we have a lot of ways to define what is urban and what is rural. So the work that I did is trying to using different ways to define it and to trying to figure out what is the spatial pattern of the different ways and what is the corresponding environmental exposure as well as the environmental health outcome. So simply speaking, what we find out is when we're using different ways, we find out actually it results in different social, urban and rural disparity patterns, and as well as the environmental association between the mortality, the health outcome, as well as the environmental exposure will also be different when we're using different definition of urban and rural. So also some work can be done using geospatial data. For example, the long-term and the short-term exposure association between the environmental exposure and the health outcome, as well as the corresponding health burdens that after this kind of exposure. So that's it. And thank you very much.
Any question from students? Yeah. Yeah.
The data itself, how did you control the data that it doesn't contain a lot of noise, hence making the model that even though you stack a lot with cloud, that's not as accurate as
Okay, very good question. So actually the model is not I developed by myself. As I just introduced it, a very advanced, very cutting edge model that developed by Amazon. We call it automatic symbol model. So the stacking is kind of using the prediction actually. So they first use a different base model to make the prediction, and then they combine them and evaluate. So if it is good enough, then they do not receive the first stack, but using the prediction to the second stack, and using the prediction to make the last step prediction, and then repeat this again and again until they find that it's robust enough, there's no improvement can be conducted, then stop it and provide the final prediction. Yeah.
is really expensive?
No, they are very quickly can be done. I don't know the real technique of it, but it's really a very powerful model. Yeah.
So it's basically base model.
Base model, yeah.
Another base.
Exactly. In the middle, they do a assumption to combine the prediction together. Yeah. Yes. Good question.
Any further questions?
Thank you very much.
Thank you.
Appreciate it.
So, okay, so let's have our final sharing. Yeah. And last, we will have a sharing from the medical sector. We have Dr. Chow Yat here, and he's the Executive Medical Director of the Quality Healthcare. And let's welcome Dr. Chow.
Thank you. So I'm Dr. Chow, and I'm from Quality Healthcare and Bupa. So Quality Healthcare in Hong Kong is called Check In Yiliu. Not sure any one of you heard about this? Check In Yiliu, Quality Healthcare. Okay, not very many. That's great because I prepare some introduction. So I'm probably gonna spend maybe 5 minutes introducing quality healthcare, and I'm also going to share a little bit about what we do with data, how we use customer data to improve their health outcomes, as well as and if any of you are interested, some internship opportunities with us. Okay. So sorry, which mouse is it? This one? Oh, there you go. Okay. So quality healthcare has been in Hong Kong for many years. So quality healthcare initially was formed through acquisition. So we previously acquired a brand that has over 150 years of history in Hong Kong. So that's why we call ourselves being in Hong Kong for over 150 years. So overall, we have around 200 doctors, 40 dentists, maybe 18 physiotherapists, around 15 Chinese medicine practitioners here in Hong Kong. In terms of clinics, we have around 100 clinics all over Hong Kong. Every year, around 800,000 customers receive services from us. So 1 in 10 people will come to quality healthcare for some sort of health or medical services. So we have different service lines, right? We have what we call Western medicine. We also have Chinese medicine, physiotherapy, dentistry. We have our own laboratory, and our laboratory does around 5 million tests every year. We have our diagnostic imaging center, so we do CT, MRI, and obviously your ultrasound, your X-rays. We do a lot of health assessments, health screening. So every year we do around 200,000 health assessments, or maybe even more than that. So to engage with our customers, we have developed our own app. So on App Store, you can look it up. If you type in QHMS, you will find our app. And this is basically our O2O offering for our customers. So customers on our app can make a booking. They can queue, similar to entering a queue in a restaurant. They can receive their medical records and even do a video consultation through our app. So just some of our services, and we also support the government. So or public-private partnership programs, government-sponsored program, basically we are a part of that program, and we are a huge part. So some of the current or most recent public-private partnership includes chronic disease co-care, which is offered by the Hong Kong government. We are serving around 12% of the Hong Kong population in this kind of primary screening. Okay. So we operate in a very interesting place in terms of healthcare in Hong Kong. We do what we call contract medicine. And what contract medicine means is a lot of our customers are actually insurers or corporates. So 80 to 85% of our customers come to us with coverage from their insurers, or they work in a large company, and the large company offer employee benefits in terms of healthcare to their employees. So what that also means is we get a lot of data through our interactions with them, because out of the 7,000 private doctors, if they are to receive their employee benefits, they sort of have to go to a narrower set of panel, what we call. So they can access the healthcare through a network of anywhere between 300 to 1,200 medical practitioners. So we are in a very unique position that we get a lot of their data, and we have the capability of tracking their progress. Okay, so that's the introduction part, right? So now I'm going to share with you what we do with our customer data and how we use technology to connect with our customers. So first thing we do is, how do our customers find us, right? How do our customers get to our clinics? The first thing we do is we have an electronic platform that allows all of our customers to do booking with us, to make an appointment with us. And this platform allows us to do booking across Western medicine, Chinese medicine, physiotherapy, even book our diagnostic imaging center. So currently, we are the only medical group that can do this in the market. And this appointment booking engine is available both on the app and also on our website. So it's really easy for our customers or for our patients to get in touch with us. In addition to that, we have a 24-hour call center. So in our call center, we have around 40 agents that work around the clock. And if you have any questions, you can call in, you can WhatsApp us, and we can resolve issues on your medical coverage, and we can also book you in to any one of our doctors. So with this kind of platform, then we created what we call a customer relations management system, so a CRM system. So if you contact us by, say, phone or WhatsApp or even email, our system will show who you are, when your last interactions with us were, the kind of, well, not all of your medical records, but some highlights of your medical records. It will also show, or it allows us to put in sort of reminders onto our system. So in case you call in, our call center will recognize that, hey, you haven't done your health assessment this year. So you haven't checked your blood pressure, you haven't checked for diabetes this year, okay? Or you haven't gotten your flu vaccination this year. So the system can tell the service agent that, okay? And for whatever reason you call in, we will know So we will serve you right there, and we will know what else you need. That allows us to engage our customer much better. Another thing that we do is we have a unified electronic medical record system. And on that electronic medical record system, not only are your clinical notes, your diagnoses, the medication that we prescribed, the investigation like blood tests, your X-ray, your CT, your MRI, all these requests as well as the results are available on our electronic medical record system. So what we also have done is, because we have our own laboratory, we connected the system between our clinics and our laboratory. So once a doctor makes a request for a blood test, you still need to take the blood, but the blood gets to the laboratory does the analysis, and the results are feedback to our electronic medical record system, and our doctors can see the results from the electronic medical record system. That created several advantages for us, because all the customers or the patients' clinical information are at one place, okay? That also allows us to do a lot of analyses. So right now, some of the things that we are doing is we are using AI to help analyze those laboratory reports. So if you come in for an assessment, we will take your blood and we will do analysis. So we may check whether you have anemia, whether there's anything wrong with your kidneys, your liver, your thyroid, among other things, right? Whether you have diabetes. While doctors are trained to analyze those results, we are actually using AI to assist our doctors. So the AI will read the results. They will summarize the results. So they do not write the reports for our doctors, but they summarize the results and give suggestions to the doctors. And so doctors can select, okay, the suggestions that the AI produced, and eventually the AI learns how the doctor likes to shape their medical reports. And what we found was very interesting. So before this, right, doctors will read the reports and they will compile their medical, they will read the lab results and compile their medical reports, okay? So after we put in AI to give suggestions, we check the level of agreement between the doctors and the AI. Over the course of, so effectively what that means is we show the doctor the suggestions, and the doctor will check off which ones they agree, which ones they want to include in the medical reports. When we first started in the first week, the agreement was around 42%. So what that means is only that our doctors only selected 42% of the suggestions made by the AI. So the AI continued to learn. So right now, the doctors is approving or agreeing with the AI 92%. So that was 3-4 months of work, okay? However, we would never want 100% agreement, because if they agree 100%, that tells me that the 100 doctors that we have employed, they're not doing their job because they're blindly agreeing with the AI, okay? So we never want 100%, right? Okay? Now, so this is a sort of prospective cohort study, right? We did something else. We did a retrospective study. So we took a bunch of medical reports that were furnished before we put in the AI, okay? And we compared the reports, right? And the agreement on that was only 53%, okay? So some people question, well, then is your AI not accurate? Okay, but when we dig deeper, that is probably not the case, because in the retrospective study, those reports were already written. So effectively, that suggests to us that our doctors actually missed around 40% of what they could have put in to the report. Because the prospective study tells us the doctors agree with the AI 92%. Okay? So these are some of the things that we are using AI nowadays. And in the next phase of our development, and this part is interesting because, as I mentioned, in quality healthcare, we do a lot of employee benefits, we call them. So if you belong to a particular institution, or if you work for a particular company, or if you are a member of a particular insurance company, more often than not, you will use us at some point in time, if not a lot of the time. So what ended up happening was we serve a lot of the working population. And because we serve all insurers, regardless of whether your company change insurers or whether you change company, chances are, even if you change insurer, you still come to us. So potentially, besides the public sector, we have the most complete medical record throughout your working life. Now, usually when people retire, they no longer have this kind of coverage and they go to the public sector. We don't want that to happen, but it does happen nowadays. Okay? What that also means is a customer who comes in, say 52, may have had over 200 consultations with us, with a primary care doctor, a GP, or various specialists, with various blood tests, various imaging done. All these records are on the electronic medical record system, but as you can imagine, if you have 200 episodes or above 200 episodes with us, it's very difficult to summarize your history, or to find that, okay, 4 years ago I did this blood test and that was the result, or 15 years ago I did a scan and that was the result. Okay, so our next phase of development is to use AI to summarize our medical records for us. And when the doctor logged in, seeing the patient in front of him or her, AI is going to generate a one-page or a short summary. Okay? The drug allergies that this person has, the long-term condition or chronic illnesses that this person has, the kind of medication that this person takes chronically, any adverse reactions to any medication, the kind of procedures or surgery this person has done, when was the last time that this person has a blood test or assessment on certain issues. So these are the things that we are looking for the AI to summarize for us. Okay? But this is only the first step, because this assists our doctors to be better doctors, to know our patients better. Okay. After this stage, the planned stage after this is for this present consultation, AI will also summarize this for our doctor. Okay. And afterwards, we are looking at connecting this with our doctor's suggestion with the CRM system that I talked about maybe 10 minutes ago. Okay. So after a consultation, you actually get a little note from the doctor summarizing that consultation, the medication that have been prescribed, and instructions or suggestions or education that the doctor has given you. Because what we found was, if you go and see a doctor for certain conditions, especially in Hong Kong, the doctors work really fast, and you get maybe 5-10 minutes with the doctor. And our experience is we are really lucky if what we share with you or what we told you, you retain 10 to 20% after 3 to 5 days. Okay, that's already really good. Okay, so in our next phase of development, this is something we are looking at. Okay. There's also a phase after that, but we haven't decided whether we want to put that into place. So that is what we call ambient listening. Okay. So ambient listening simply is during the consultation is recorded, and AI will identify the language and then summarize the whole consultation. But we haven't decided whether we want to do that yet, because some of us or some of our team members thinks that just a tad too creepy. But we'll figure that out later. Okay. Now, with all these, what can we do? So what I've just mentioned right now is what we use customer data and our technology to serve individual customers. But what else can we do? We can also aggregate this data. And we do this all the time. We actually segregate our customers into different industries: hospitality industry, construction industry, financial industry. And we can actually pool their data. And we can actually identify what conditions are most common in each of the industries, what are the top 10, 20, or even 50 most common diagnoses, the most common procedures done, and whether there are any, when it comes to finances, the most expensive or complex procedures or medications prescribed. So on a regular basis, we will have that feedback with our customers. And in this case, the customer is usually the corporation whose employees are coming to us for their health services. And we analyze the data and we feed back to them. So for instance, in the past year, you seem to have a large number of musculoskeletal problems in your employee population. So a lot of back pain, a lot of shoulder pain, this kind of thing. Then we make suggestions on preventions with them, and we work with them to create products, to create things that can potentially help reduce employee sickness, reduce days of work, that sort of thing. So on a population basis, that's what we do. Okay. And because every year we have around 3 million attendants in all of our clinics, there's a lot of data that we are currently storing. So in the past, our Western medicine, Chinese medicine, and dentistry, the data is stored on different systems, but that changed at the end of last year. So at the end of last year, we decided to put all of our data into one single data lake. Okay, so we created an ODS for customer data. And what that also means is, with that, we can do our analysis much quicker, and we can find, or we can provide a single view of customer. Okay, so what that means is, in the past, I may go to my general practitioner for consultation for cold and flu. I may have hypertension, and I go to another doctor or specialist for my heart disease or hypertension or diabetes. I may go to a physio because I twisted my ankle a while back. And every year I go to my dentist for my scaling and polishing and assessment. In the past, we know that I'm a customer in each of these businesses or business line. Okay. But it was very difficult to combine the data because they are sitting on different systems. But with an ODS, then we can find a single view of customer. So I get a unique customer number, and with that number, the system can tell me how many times I visited our dentist, our general practitioners, our specialists, and the kind of lab tests that we have done. And again, this kind of data is feedback to our customer relations management system, so our CRM system, to provide what we call nudges and reminders to our customer so that they get, well, basically more comprehensive health services. Okay. So I would just like to pause there, right? And see if you have any questions before I get into whether there are any opportunities for internships with us. No? Yeah. Okay. Can you tell me a little bit more about your what you're thinking about your topic and what you plan to do?
Instead of like 85-year children, no, yeah.
Instead of by their what? Yeah.
So there may be some problems like some technologies.
Yeah.
Don't know how to communicate with doctors accurately.
So that's a common occurring. And with that, I think you're thinking a lot about the public healthcare system. So they go alone and they may, even because of their age, they may have some cognitive impairment and they can't communicate very clearly or quickly their concerns. And they only get 7 minutes with the doctors, and so a lot of this is well, maybe not neglected, but missed. So some of the things that we do, again, with our system, because we know our customer and we try to summarize their history. So even in someone who is elderly, right, with multiple medical or surgical problems, it's still easier for our doctors to get a more holistic view for that patient. And we really advocate the concept of family doctor. So if you have visited a doctor and you come back, you book for another appointment, okay? First of all, you can choose the same doctor. Even if you don't, we will ask you, do you want the same doctor? Okay? And that creates a better continuity of care. Okay? Because a lot of this, and you have to understand, especially for the elderly, a lot of the problems cannot be identified through one consultation because they may be coming in with multiple problems, right? And if they are attending a consultation, sometimes it's difficult for the doctor to cover 3 or 4 different aspects because there just isn't enough time. In the private sector, this may become easier, especially if you frequently come back to the same doctor, right? Some of the issues that are on your mind, if you don't get a chance to discuss it today, you can discuss it in your follow-up appointments. And generally, in the private sector, the follow-up appointments are closer or shorter intervals. So in the public sector, you may not come back in another 4 to 6 months. But in the private sector, you usually come back a month or 2 months. So it's a lot easier to pick up these kind of issues, especially for elderly patients. because when they see the same doctor again, the doctor already knows what happened in the last consultation, and then there's a progression from that. Okay, and in each of the consultation, our doctors will learn a little bit more about the patient. Okay, we also especially design certain health assessments for our elderly patients. Okay, and when we design a lot of our clinics, we, in terms of our wayfinding, in terms of even in our apps, we designed it so that it's relatively easier for elderly customers to use. So there is, we actively look at to book an appointment, how many buttons you need to press, how many clicks you need to produce, that sort of thing. We are looking at easier registration process for our customers. Okay, that includes using sending a customer a QR code. To register. We also enable family members to add their parents or dependent, okay, onto their apps. So one person can manage the whole family together. So if there are, so the son can book an appointment for the elderly mother. If the if the elderly mother consents, the son can also look at medical records, medication prescribed, and next appointment for the parents. So these are some of the things that that are already in place to serve our elderly population. Yes.
You mentioned that all doctors from your institution have been receiving assistance from AI tools. So I wonder what kind of AI tools is that AI developed successfully for the basic industry, and since the doctors has been using AI for assistance for a very long time, like for 1 year, 2 years maybe, in the future they will develop this kind of dependency on this tool. As I know, AI model are really trained by using old data from years ago. So is there some kind of limitation? There are some kind of risks for doctors to limit their performance. You know what I mean?
Yeah. So it's a very good question. I don't have a straightforward answer to that, but our doctors using AI is still within the last 6 months that we have developed this, and we are very fortunate, and this may be a good tie-in with internship. So we are very fortunate, and we are investing in the business. That we have data scientists, we actually have AI specialists in-house. So our AI model is developed in-house together with our doctors. Currently, the AI is still learning. Okay, and again, I'm not an AI specialist. I'm not sure if they are going to take over the doctor's role in the future. My feeling is that AI is not. Okay, our current impression is that AI is making our average doctor better doctors. Okay, because now our doctors are able to communicate better with their patients. So my background is I'm a psychiatrist. And in my line of work, I need to do a lot of listening and I need to do a lot of explaining. Okay. In the 200 doctors that we have, some are better at explaining than others. But AI, providing some suggestions, allow our doctors to engage in more meaningful discussion with our customers. So they actually improve the communication skills of our doctors. Now, one thing we have to be aware of, and we are constantly tracking is AI hallucinations. And so naturally we want AI hallucinations to be 0. Currently, it's not the case. It's 8%. That's why everything is currently being screened by our doctors. Okay. Again, at least at the moment, we are seeing our doctors responding to customers or patients quicker, and the kind of interactions is improving. There are no more questions. Any other questions? Maybe just a word on perhaps potential internships with us. I mean, if any of you are interested. So we currently have quite a few. How do I do this? Does that work? Yes. We actually collaborate with a few universities like Chinese U, some Hong Kong U as well, in the Department of Public Health, pharmacy, I think nursing maybe, and some universities on that have MLT, medical lab technician. They will spend some time with us. It can be a month, it can be a few weeks, just to get an idea of how the organization works. If you do spend a month with us, then we will actually put you to work. So you will work side by side with our colleagues. And it can be, if you are interested in tech, work with our IT team. If you're into AI, I place you with our data and AI team. If you just want to understand how healthcare works, we can actually place you with our operations team. So you understand how healthcare is being organized in Hong Kong, in the private sector. If you are interested in marketing, we have that as well. Okay. So if you're interested at all, or if you have some interesting idea or collaboration you would like to share with us, please feel free to contact me. Okay. So I think, yes, right on time. Thank you.